Let's talk about naming alkenes and alkynes. And this is going to be part one because we're going to restrict ourselves to just having one of those groups on the molecule for now. The next video will expand it to having more than one. So, like before, we will identify the longest chain. Longest carbon chain. However, we're going to add an additional factor. The longest chain must contain the carbon double bond to carbon, as in the alkenes, or the carbon triple bond to the other carbon, as in the alkyne. So these have to be present in the longest chain. And we're going to end the name for an alkene in E, and we'll end for the alkyne in Y in E. So it's very similar to what we did for alkanes, except we're changing an A to an E or an A to a Y, depending on how many bonds we have. So let's do an example of this. So here is a molecule, and you'll notice that there's the longest chain right here. 1, 2, 3, 4, 5, 6, right? And that's what we would have done, except that there's a double bond, and that double bond is not completely contained in the longest chain. Only one of the carbons. Has to be both of them. So the longest chain is actually starting from here and going to there. So 1, 2, 3, 4, 5. So this is a pentene, not a hexane, because of the double bond taking priority. So let's name this. And we're going to count giving priority to the double bond. So we'll count from here rather than from there. And we say 1, 2. So this ethyl group is on the second carbon. So we're going to say 2 ethyl. And then since this is a 5 carbon long chain, pent. And then for numbering the position of an alkene or an alkyne, either one, we go with the lowest number possible. So we're going to say this is the number 1 carbon, that's the number 2 carbon. And so how do you identify where the double bond is? Well, we go with the lower of those two numbers, which is 1. So pent 1 ene. Let's look at another example. So we have a cyclobutene right here, because there's a double bond in here. Not very good for ring strain, but you can make this. And we have a 5 carbon long chain on it. Well, this 5 carbon long chain does not contain the double bond. So this is not the longest parent chain. The ring is. Without this double bond here, then the ring would be a substituent, but with it, the double bond takes priority. So we'll start counting, and since it's inside a ring, we always number the carbons 1 and 2, the lowest they can be. So this will be carbon number 1. This will be carbon number 2. This will be carbon number 3. We could start numbering this as carbon number 1. That is carbon number 2. then this one would be 3, that one would be 4, and that would make this a higher number, so we go around the circle this way. So this will be 3, and then that's a 5-carbon long chain. Pentyl. And then because we know that the position of a double bond inside a ring will take priority, we don't have to number where a single double bond is in the ring. So we can just call this cyclobutene. And that E is telling us the double bond. Let's look at an alkyne now. And again, a lot of times I like to draw out the carbon just because it kind of starts to blend in a little bit without it there. I'll draw it without it here in a second, and you'll kind of see why I like it. So we want to prioritize the triple bond being the lowest number, and it has to be part of the longest chain. So if we started counting from here, 1, 2, 3, 4, 5, that's a smaller chain than from here, 1, 2, 3, 4, 5, 6. So this is some kind of hexyne. Now, where do we start counting? Well, if we start from here, 1, 2, 3, 4, we first encounter a carbon as part of the triple bond on the 4th carbon. If we start counting from this side, we go 1, 2, 3, we encounter the yne on this 2nd carbon. So this must be numbered in this direction. Like so. And so this would be called 4-methyl, because there's a methyl group right here. And then hex. And then since this starts at the number 2 carbon, we say 2-yne. Like so. And before I get too far ahead, I'll just draw this without the carbons specifically labeled here, and you might see what I mean. Sometimes this is okay, but a lot of times when you're in a computer program, it will look like this because there won't be any gap there. And I think it makes it a little bit harder to read than when versus when you draw the carbons in. But if you're neat, in either case, it can be okay. You just have to be careful. Now, let's see here. So we number, so the unsaturated bond is the lowest, and we pick the lowest number to locate. Went over that. And on a ring, the double bond or triple bond is always located at C1 and C2, in between those 2 carbons. So if there's only 1 on the ring, you don't need any numbering for the bond. So let's do a few more examples now. And so we have this molecule here. It's a cyclopentene kind of molecule. We've got a double bond right here. And so either this carbon is carbon 1 or that carbon is carbon 1. And then the other one is the second one. And so if we're counting around the ring and we want everything to be the lowest, if we started here and counted 1, that one would have to be 2, then this one would be 3, that would be 4 and 5. So that's putting these chlorines at 4 and 5. Now, if we count the other direction, 1, 2, 3, 4, you'll see that the chlorines are at a lower number. That's the correct way to go around this particular ring. So this would be called 3,4-dichloro cyclo pent, and then because we know where the priority has to be because of the rules, we do not need to locate this double bond. So it's just cyclopentene. And then from there, you can draw this based on the rules of the molecule. Let's look at a few more examples. So here we have a molecule, and you might think, oh, well, we number it so that the substituents have the lowest numbers. And so if I started counting from here, that would put the bromine on carbon number 1. And then I would have this one on a higher number, but overall it would be lower. No, not in this case. We prioritize the double bond. So because of that, we're going to count such that the double bond is at the lowest number. And then whatever else happens, happens. So here we go. 1, 2, 3, 4, 5, right? So this is actually on the 5th carbon, not on the 1st carbon, because if we started counting from here, 1, 2, 3, the double bond would be on an earlier carbon. Or I mean, on a later carbon, it'd have a higher number. So this is the 2nd carbon. That's the 5th one. So this is 5 bromo pent. And then this is on carbon number 2. 2. Well, it's between 2 and 3, but you always pick the lower of the 2 numbers. Ene. Like that. Now, what happens if we have a molecule like so? And in this case, if we start counting 1, 2, 3, that's the same as 1, 2, 3, because the double bond is right in the middle of the chain. Well, in that case, then we use our other rules from alkanes and other substituents to break the tie. So here, if we started counting in this direction, this would place the methyl group on a much higher numbered carbon. So we'll count from this side. So this is on the 2nd carbon, and in either way of counting, the double bond will be on the 3rd carbon. So we choose it so that we get the lower number on the other substituent when there's a tie between either side. So this is 2-methyl hex 3-ene, like so. So you can see up here where the double bond took precedence, decided which way to count in that direction. And you can see down here where it was right in the middle. That can't be the only deciding factor if there's other things that need numbering. And so then you go with the other rules. I've got another example here. Just one more. Just like so. So this is an alkyne because we have a triple bond here. And we'll need to start counting so that the triple bond is encountered first. So if I start counting from here, 1, 2, 3, 4, that's on the 4th carbon. If I start counting from here, 1, 2, 3, that's lower, so we have to count in this direction. So this is a heptyne, and the methoxy is on the 6th carbon. So 6 methoxy, hept. And then on the 3rd carbon is the alkyne, hept3-ine. So that's the basics about naming alkenes and alkynes, assuming there's one of them on the molecule at a time. Thank you, and we'll see you in the next video.